All right, guys, so we are finishing up our lecture on linear motion. So this is on page, this is on page 26 of your packet. We're going to go through that. So we're going to learn about average speed, average velocity. I don't know what's going on. Okay, so terms to know, average speed and average velocity. These are the equations to know. And so we are going to use definitions in words, motion diagrams. You already know that. We're going to be using graphs and relationships. Okay, so an object is moving at 5 meters per second for 5 seconds. What does that mean? So on page 26 of your packet, we want to take a look at that data table. So that means at 1 second, it's gone 5 meters, right? And then after 2 seconds, it's gone 10 meters. After 3, it's gone 15 meters. After 4, it's gone 20 meters. After 5, it's gone 25 meters. I know that because it's going 5 meters every second. So 5, 10, 15, 20, 25. All right, so if we graph this, we start at 0. Let's make my pen a little bit bigger. Okay, you start at 0. Then after 1 second, you're at 5 meters. After 2 seconds, you're at 10 meters. After 3 seconds, you're at 15. After 4, you're at 20. And after that, you're at 25. So you start to see this linear pattern coming out. So what does that mean? What would a distance time graph look like for a constant velocity? Remember, it will be moving the same amount every interval, so it would be a linear graph. So what part of this graph is constant? That would be the slope, right? The steepness is staying the same. That's kind of what we talked about in class today. What are the units of slope? Well, if slopes rise over run, we look at the units of our rise over the units of our run, and we get meters per second. And it's important to remember that the physics, the slope of the graph has units. Okay, so now we're on the other side, page 27. Check for understanding number 7. We want to rank the speeds of the objects A, B, and C. So who's going the faster to who's going the least slow. So the answer would be A is the faster because it's the steepest, then B, then C. So now we want to draw a motion diagram. So A would have a motion diagram pretty far out. B would be a little closer together. C would be a lot closer together because it's moving a lot slower. All right, number 8. This is a stationary object, so draw a distance versus time graph for an object standing still. Well, let's see, it starts at 0, okay? After 1 second, it's still at 0. After 3, it's still at 0. After 4, it's still at 0. After 5, it's still at 0. So if this is 0 meters, it's staying there the entire time, okay? It could also stand still if we did another try. Let's say it stands at 3 meters. It's just staying there the entire time. 1, 2, 3. It's staying still at 3 the entire time. All right, so now if we graphed velocity, which is what I went over in class today, what would the velocity versus time graph look like? It would be moving the same amount during every time interval, so it would be a horizontal graph. Okay, it would always look like this. So checking for understanding number 9, there are 3 objects, a car, a truck, and a bike. Here are their speeds. Draw a distance versus time and a velocity versus time. So here's my distance, which is the same as, position, just the vector is position. So a car traveling at 0 meters per second is not moving, it's staying in the same place. A truck going 10 would be having a very steep slope, and a bike might have a medium slope. Okay, so this is the truck, this is the bike, and this is the car. Now for a velocity graph, if I graph their velocities, the truck is moving fast, so it's got a fast constant velocity, so that's the truck. The bike's moving slower at a constant velocity. And then the car is standing still, so the car is on the 0 velocity line. So we look at the slope of this guy to graph here, slope of this to graph here, and the slope of this to graph here. All right, so here's a motion diagram. Which distance time graph matches this motion diagram? So we see some dots pretty close together, and then they get farther apart. So that would have to be a lower slope and then a higher slope, because this is slow and this is fast. All right, here is, which of the following is the velocity graph? Well, if it was slow and then fast, but constant velocities, we have to have a low constant velocity and then a high constant velocity. So C is correct. Here we are with a velocity time graph for a hockey puck. So which of the following distance graphs match this? Sorry. So we have a positive constant velocity and then it stops. So we'd have to show something where it's moving forward at a positive velocity and then it stands still. So D is the correct answer there. All right, we're going to continue on to finish up with the equation. Target 4. Target 4 talks about average speed and average velocity. So average speed is the total distance divided by the total time it takes to cover that distance. So we have distance divided by time. Remember that speed is a scalar quantity, okay? It is described with magnitude only, so something like 2 meters per second, okay? It doesn't tell us what direction it's moving in. Average velocity is the rate at which position's changing, so it's the total displacement divided by the total time. So we're going to say average velocity, so if I put this bar over that, that means average, equals the change in the position divided by time. So this means change in the position, so displacement divided by time. Velocity is a vector, meaning direction is required. So positive, negative, up and down, left or right, north, south, east, or west. All right, so when an object moves straight ahead and does not change direction, distance and displacement would have the same value. Speed would be magnitude and velocity would include direction. All right, so when we analyze word problems, we need to do these things. So first you're going to identify givens in a word problem. Then you're going to identify the unknown, write the equation, substitute numbers, and the correct answer with units. Okay, so these are the steps we're going to take when we solve word problems. So here is our equation. So velocity, average velocity, that's that V with the line over it. Change in D is the displacement, and T is time. All right, so doing a word problem. A car travels a length of road for 320 meters. Assuming the car travels this distance in 11 seconds, what speed is the car traveling? So we want to identify the information given in the problem. So making a list of variables can help us figure out what equation we can use. So that's the first thing. So I would say, okay, we know it's 320 meters. We know it's 11 seconds. Okay, that's what's given to me. If I want to know what speed is, so I'm looking, that's my unknown. I'm looking for speed. Okay, so that's the first step. Step 2, write the general equation and variables to be used. So if I have speed, I know that equation. I know speed is equal to distance divided by time. Okay, so I've got that step down. Finally, you can substitute numbers in. So I can say speed equals 320 meters divided by 11 seconds. Okay, so that's the substitution step. And finally, I can actually calculate that. So 320 divided by 11, I get 29 meters per second. So that's the answer with the units. Okay, so that's how we solve word problems. You guys are done.